Okay, ladies and gentlemen, let's talk about linear equations. Now, of course, anytime you start talking about linear equations, you're going to be talking about straight lines because, of course, anytime you type the word linear, you have the word line in it. Now, a linear equation is indeed a straight line. Now, one thing about this line is it cannot have any curves. It also must be continuous, and it must go on forever and ever in either direction. As far as equations go for straight lines, we're going to have a couple here. We're going to have standard form, and that is ax plus by equals c. That's going to be standard form. Now, you're also going to have slope y-intercept form. That's going to be y equals mx plus b. You will also have point slope form. Point slope form is going to be y minus y1 equals m times x minus x1, where y1 and x1 are components of a point, and m, of course, is a slope. Now, those are just some basic formulas that we're going to have. You're also going to need to know m equals y2 minus y1 all over x2 minus x1. Pretty classic there. So all of this linear equation stuff comes back to graphing straight lines. So if we just go very basic, if I have a straight line, there are a couple components that it has. Where it crosses the y-axis, we have a point. This point right here is called the y-intercept. And where it crosses the x-axis, right here, we call it the x-intercept. The reason we call them the x-intercept and the y-intercept is because it's where it goes through the y-axis and where it goes through the x-axis. Now, the y-intercept has a unique form to it. The unique form of this point is it will always be 0, something, because if it always has to land on this line somewhere, we're not going left or right, anything at all, but we're going a certain amount up or down, Now, the x-intercept, on the other hand, the x-intercept is going to have a different form. It's going to be something, 0, because it's always going to be somewhere left or right, but it's never going to be up or down. So it has to be somewhere on this axis, in our case, something, blank. So you have this. Now, each line has a certain amount of slope. And slope, we have an equation right over here. M equals y2 minus y1 over x2 minus x1. A way we remember it is rise over run. But just remember, this is not an equation. This is simply a way to remember an equation. So you have those types of things. Now, slope can either be positive, which means from left to right, it rises. Okay? Slope can be negative, which means from left to right, it falls. Or, of course, you can have two other situations. You can have a slope of 0, which means that there is no rise, there is no fall on this particular graph. Now, there is one other situation in which slope can arise, and that's where it is undefined. Undefined slope is going to be a slope where it goes straight up and straight down. Straight up and straight down would be undefined. So you have 0 slope, you have positive slope, positive, 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 until it gets perfectly vertical. When it becomes perfectly vertical, it is undefined. Now, if we're to go negative and go down, 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 down until it became vertical, that would also be undefined. So we have undefined slope, positive slope, negative slope, and a slope of 0. Now, we've already talked about those basic things. Let's talk about how we can graph a linear equation. The first method to graphing a linear equation is to use a t-table. Use a t-table. Now, it is exactly as it sounds. It looks like a big old T, and you have x values over here, and you have y values over here. And what we're going to do is we're going to put x values in and see if we can come up with some y values. So if I have 4x plus 2y equals 8, 4x plus 2y equals 8, I can use a t-table and equation to graph this line. Now, let's talk a little bit more here before we move ahead. We have x, which is called the independent variable. And it is independent because I get to choose. You get to choose what you put in the independent variable. A lot of times we're going to choose -2, -1, 0, 1, and 2. And that's going to be a pretty common grouping. This way we have somewhere where it goes through the y-axis. We have something a little bit to each side. Over here, this is called the dependent variable, because a dependent variable depends, comes out of whatever this is. And this has to do with our function system. When we have a function, that means we're going to take an independent variable and we're going to put it in. We're going to run it through the function, and when it comes out on the other side, it's going to spit us out a dependent variable. So in essence, we take x's and put them in, and out it comes as a y. Okay, the other way to think about this is we plug in a domain and it spits us out a range. Now, the problem here is we have 4x plus 2y equals 8. That's a fine equation. However, if I try plugging in 4 times -2 plus 2y equals 8, I now have to solve this every single time. And it becomes a real pain because just to get one value, I end up having to make about 5 or 6 steps. So I come up with +8. However, if I were to take the equation and solve it for y just once, so I take 4x plus 2y equals 8, subtract 4x from both sides, those go away, and I'm left with 2y equals -4x plus 8, divide by 2, divide by 2, divide by 2, y equals -2x plus 4. Now I can plug them in very quickly, and having solved just once, can use this easily. So y equals -2 times something plus 4. Well, let's start by plugging in -2. All right, y equals -2 times -2 is 4, plus 4 is 8, and that's what we put over here. Now, on the other hand, I could say -2 times -1 plus 4. That's going to be 6. -2 times 0 plus 4 equals, well, that's gone. That's going to be 4. And -2 times 1 plus 4 equals, now -2 and +4 are going to make 2. And I have -2 times 2 plus 4, which is going to be 0. Now, you'll also notice we got a couple things. We have -2, 8, -1, 6. We can make coordinates out of these points. We have 0, 4, which is going to be our y-intercept. And then we have 1, 2. And then we have 2, 0. And this is going to be our x-intercept. So it works out really, really nicely. And all we have to do is graph it. So here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And it starts to look really good here. In this case, we're going to say back 1, 2, and up 1, 2, 3, 4, 5, 6, 7, 8. Back 1 and up 6. 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. Up 1, 2. Up 0. And now I have a whole bunch of points, and I can graph this line. Now, one thing you always want to make sure you do on every single line you do in this class, you must put on a label. Now, you could say 4x plus 2y equals 8. That would be a perfectly fine label. Or alternatively, you could put on y equals -2x plus 4. Either case is correct. There's just two different forms of the line. You'll notice this line falls from left to right, so its slope is negative, and we'll get into a little bit more of that later. The problem with graphing points for graphing a line, so plugging in a bunch of points, is it's going to be a very long process. So there's plugging in some points. I want you to do the following. I want you to use y equals 3x minus 2 and do the following x and y table and give me a graph. So -2, -1, 0, 1, and 2. And I want you to give me all the values for y, and then I want you to graph it. So solve and graph. There is the homework from that section.